Greetings, good afternoon, good morning, good evening. So, bit manipulation, when we directly manipulate the bit of the entity, like if it is, for example, 2, then it can be represented as 1 and 0. This is 1, this is 2, this is 4 and 8. That is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so 3 would be represented as 1 and 1. So when we manipulate a bit of an entity, then we generally use bit manipulation, and bit manipulation is a technique which enables us to execute or to work fast, because it directly works on bits, so it is faster than usual methods. Okay, so we can use AND or not, set or XOR. Main function would be set bit, get bit. Please bear with my handwriting. Count, set bit, and so. So if I talk about AND, let's do AND 2 and 3. So this would be 1 and 0, 1 and 1, 0 and 1. Because this and 1 and 1, this would be 1. So this operation would return 2. Similarly, if I do 2 or 3, 1 and 0, 1 and 1, this would return me 1, and this will also return me 1. So total would be 3. If I do XOR 1 and 0, 1 and 1, not similar bits, 1, similar bits, then XOR would be 5. Now let us move forward and see one question. This question is very basic and a really nice question. I hope you can give it a try, pause the video, read the question, and let's start. Very easy. So in this, it is given that it is a non-empty array of integer. Each element appears twice except 1. So for example, 2, 2 and 1. In this appears twice, but this don't. So we have to return 1. Similarly, 4, 1, 2, 1, 2, and yeah. So this appears twice, this appears twice. We have to return 4. Okay, so first approach could be like a brute force, in which we can run 2 loops from I0 to M, and then JI to JI plus 1 to M, and search if this element exists in rest of the array or not. If it doesn't, that means it have a unique appearance, and we can straight away return it. This would take n square. Second approach could be a little more intuitive. We can do n log n, that means sorting, and then if for example, like 1, 2, 2, and 4. If a element is repeated, then it will surely exist ahead of it. So if this exists one more time, it will exist only here. So we can just have to traverse and check the next element. If it doesn't exist, then we can return 0, and we can iterate, like if it exists, then I plus 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 two times. One will jump here and another will jump here. So this will take around n for sorting plus n for traversal, which would return n log almost. So this is the method. And another method is to use XOR, and we can solve this into n. How XOR? Saying it would return 0. Remember? So if I'm having a number twice, example 2 2, that is 1 0 and 1 0, it will return 0 0. Similarly, and when we XOR with 1, that is 0 and 1, it will return 0 and 1. So this I can do any number of times. And a property of XOR which help us, that is A XOR B is equal to B XOR A. Doesn't matter in which sequence we are going to perform XOR on these operator, like 4 1 1 2 2 or 1 2 1 2 4. In both the cases it will return 4 because don't have 4 to make the unique element 0. So this simply you can run a loop from I0 to n and keep XORing the elements. XOR. So this is the symbol of XOR in C++, and we can say RRF and just return that element after the loop. Written XOR. So this is a very basic question, but yes, an intuitive one, and the best part of this is how we take it from n, how we take it from n square, then to n log n, and then to n. So you can have a good discussion if this question is asked. This would take a little of time, and the interview would be happy. You can also give one more method, like hash table would be one method. You can just keep storing a hash mark. You can just keep storing like 2 2 1. So 1 is 2 times, 2 is 2 times, and 4 is 1 time. You can traverse and return the element that has unique time, 1 time. 4. This could also be a method, and it would take O of n, but O of n space also. But XOR will take O of 1 space. Second question is same, like single number 2. What we had did was single number 1, now we are going to do single number 2. In this it is given that like in the previous question this is given twice, and we have to return 1 since it is unique, but rest of the element appears twice. But in single number 2 we have to return the single number which appears only once, but rest of the element appears thrice. So in this, simple XOR won't work, because in XOR, if we do XOR, then this and this will meet and it will make it 0. Then and then this and this will meet, it will result the XOR of 2 and 4. So think about it, that how we are going to do. So the first approach could be similar like n square. Yeah, for loop, 2 for loops, simple. Then we can go to hash map. No, oh, why will we go to hash map? Let me first go to so sorry. Let me first go to log n. Yeah. So log n is sorting, and you can just see if 3 appears together after sorting. Then we can just move to this element, and then we again see if next 2 elements are same to this, and then we can move to this. So that this traversal would take n and sorting would take log n, so the won't return time complexity as log n. Next approach could be hash map, that is n, but it will take time complexity as n, and also the space complexity as O of n. So what next? N approach, yeah. So one approach could be since if I take this example only, 2, 2, 2 and 1, so that this would be 1 and 0, 1 and 0, 1 and 0 and 1. This bit would be 3 times and this would be only 1 time. Similarly, if I had 4 3 also, then the bit here would be 3 times, and rest of the bit would be less than that. So what we can do is we can analyze it, and we can think of an approach where we can use this property that it is appearing 3 times. Okay, so our approach is going to be O of 32, which is kind of similar to O of n, but only when n is larger than 32. Okay. N is way more than 32. Okay. So what we can do is we can start a loop from I equal to 0 for I is less than equal to 32 times, right? I plus plus. And what here we can do, we can create a variable check, and what it will do, it will just move check bit by bit starting from 0, and we can take another variable count as 0. In this we can have a loop for auto n and nums array if we have. Then if um, n and check r1, like then this would be true, and we can do I plus plus, I mean C plus plus, C count plus plus, and then if count not 3 is 1, matlab it's not 0, that means that bit is set in our answer, then we can just do answer or equal to check. Now let me just go line by line. It will run for the whole 32 bit number. It will run for the whole number bit by bit, that is 32 bit number. So starting from 0, then I write 0. So here 1 is set. So this line I is 0. So here 1 is set, and we will check how many 1 exist since count is 0. So we will check for each number in the array. Each number for each number in the array we will add with check. Means this bit only set, like for example this. So here 3 would be 1 and 1, 2 will be 1 and 0, and 1 would be 0 and 1. Okay. So in this last bit is set of this and 3 times 1, 3 times. So if I count how many bit last bit set, so it would be 4, yeah, and 4 mod 3 would be 1, not 0, of course not 0. So this means our unique number has this bit set in the result. So we can just OR it with 0 and answer would be 0 in the starting. So when we will keep ORing, the number would be our answer. So this is a very simple approach in which we are running a loop from 32, and this is n. This will run for 32 times, that is a constant, and this would be n. Single number 3. Okay, so we have done single number 1, single number 2, and now this is single number 3. Single number 3. We have to find 2 unique elements. I repeat, 2 unique elements, and rest of the element appears only once. So 2 of the element would appear twice. Two of the element would appear once, and rest would appear twice. Twice we can use XOR, of course. Let's see how. So a 1, 2, 1, 3, 2. So in this 2 appears twice, 1 appears twice, and 3 and 5 appears only once. Our result could be 3 and 5 or 5 and 3. Both are acceptable. Okay. So if we XOR the array, full array, if we XOR, then the result would be 0 1 1 1 1 0 0 1 1 0. This would return 0. That is 1 XOR 1 XOR 2 XOR 2 would return 0. Now 3 XOR 5 would return, that is 0 1 1 1 0 1. This would return 1 1 0. So first different bit, that is you can see last significant bit. First from the last. So last significant bit would be second. So and this bit would be same. This could be 0 and 0 and 1 and 1. So we can make two group on the basis of last significant bit. Why only two groups? Because we know there are exactly two unique elements present in the array. So let me make two groups. Let me write some code and then we will go line by line and understand how we are going to approach it. With x and x of minus 1. No. So d is equal to x and not of x of x minus 1. What this will going to return, x is the full XOR of the array of n, and d will give us the last significant bit, that is the second bit in our example. Okay, for auto we're gonna traverse in full array with the array nums. So if t and d, that is in both the element this last significant bit is set. So d2 will have the last significant bit set, that is 1 0, the rest would be 0. And t we are checking if t has the last significant bit set or not, and if it is set then we can choose t1 XOR t, and similarly else t2 XOR equal to. Simple, very intuitive and very simple. We are going to traverse in each element of the array, each element I repeat. So in this, when we keep on XORing, we'll see with the example. I hope this is visible. So, see, in this example, 1 we have written as 0 and 1, 3 we have written as 1 and 1, 2 we have written as 1 and 0, and 5 we have written as 1 0 1. So okay, so now significant bit. Second was the bit in so 1 is twice and 2 is twice. Okay. So in this would we need answer as 3 and 5. So in this see 3 and 5. Last bit are same. Only second last bit of both of them are different. So we are going to make two group on the basis of second last bit. If at all it would be something odd, then also it would end up in the same group. All the number of, like if it would be 7, then all the 7 would end up in three group, second group, and in second group all 2 times 7 would 2 times 7 XOR would be 0. So we will anyway get the answer. So in this step we are just checking if the second bit is set or not. If it is set, then T1 would be 3, and if we will see 2 also has a set bit in the second place, but 2 times 2 would get XOR in T1, which would return 0, so T1 will only have the value 3, and T2 will have 5 and 2 times 1, but 2 times 1 will return 0, so T2 will have the value 5. So the answer would be 3 and 5, T1 and T2. Thank you.